All right. Let's
Live
see.
now again? Yes.
I
Maybe?
believe it's trying. We're trying.
Yes, no, maybe.
It's starting. So.
Okay.
All right.
Live
We're
again.
live now. Hopefully
Can
you
you
can hear
hear
us. Also, there's no one watching yet, so we're working
I'll
on
just
it.
hold this up until we get verification.
There we go. Okay.
2 people.
2 people. All right, folks. We have our lovely thing. Can you hear us at all?
Yes, no, maybe so.
Let's hope so. Oh, we've got more viewers. Awesome. Yay! Thanks, Joanne!
We fixed it!
So we're very lucky to get, yay, thank you, Amy. We were very lucky to get an extra computer tower because someone upstairs got a new computer for our new system, and so we got to replace it, but we forgot to fix it. So, and make sure we had the right input. So thank you guys for bearing with us. Awesome. Sharon, your boys Tony and Austin can hear you. Awesome. Thanks, guys. And Elaine, thank you. 18 folks. Perfect. All right. Thanks for bearing with us. Today, we are going to be talking about amphibians, which is a very special group of animals. And you guys missed it, but Emily here maybe at the end will show you how she can hop like a frog. And if you guys want to hop like frogs around your living room, please feel free. It's really fun for most of us. Now, amphibians are a very special group for a few different reasons. Amphibians are cold-blooded, much like the reptiles, much like fish, and also sort of like our invertebrate friends that we talked about last week. They also have a have a backbone. There we go. The backbone is right there with Miss Emily. And so they have a backbone. It doesn't look like that. It's not that big. There's not an amphibian not that big.
Can you imagine?
I think the largest amphibian is long, but the backbone's not that big. It's huge. Anyway, amphibians have a backbone, just like we do. But there's a lot of differences other than the backbone right there. Obviously, we're warm-blooded, where they're cold-blooded, but the biggest difference that I think is really cool to talk about with amphibians is their skin. Now, reptiles, especially snakes, are often thought of as slimy, right? Everyone looks at them, they have shiny scales, and often they're cold to the touch, which to our brains means that, oh, this thing is slimy. But if you actually look at your fingers after you touch a snake, chances are you're not slimy unless it's trying to pee on you, right? But amphibians are slimy, and they have to be most of the time because they breathe and drink through their skin, okay? So that's really key. Not many other animals do that. In fact, I don't think anyone does except for the way insects breathe is a little bit weird. But breathing and drinking through their skin, they absorb it through their skin. So to be able to absorb oxygen and be able to absorb water, their skin has to be wet at all times. We'll just turn that off right there. Perfect. Okay, so they have to be slimy most of the time, right? Which means they can only live in certain environments. But there's a lot of adaptations that certain desert amphibians have that allow them to live in a desert. So there's a lot of exceptions to that rule of being slimy, but for the most part, the amphibians, alongside our fish friends, are the genuinely slimy animals of the animal kingdom, okay? Now, fun fact about amphibians, there are about 7,000 known species, which is quite a lot. I think it's about equal to mammals, or very close to that. Mammals are a little bit less, I think, known species. However, it's estimated that there could be hundreds, if not thousands, more unknown species, because amphibians can be kind of hard to find sometimes, especially if they live in an environment where they're going to be hiding. Now, we have 24 viewers, awesome. In case you guys didn't know, my name is Educator Katie.
And I'm Educator Emily.
And we're going to talk about amphibians today, which includes frogs, salamanders, and caecilians. Caecilians are basically, they look like giant worms, but they have a backbone.
They're legless lizards, also called that.
Even though they're not reptiles.
Yes.
That's confusing.
It's really
because there are actual legless lizards that are reptiles too.
It's weird. Yeah, I've heard it used both ways.
Both ways.
It's just,
cool.
It's confusing.
So we got lots of confusion there. But the frogs and toads are by far the largest group. There's about 6,300 known species of frogs. Okay, so there's tons of frogs and toads across the world. And what makes a frog and toad different from, say, a salamander is their body, right? You might have noticed Emily was trying to show us the shape of a frog earlier. Their arms and legs are specifically set in certain ways. There we go. This is the word I'm looking for. And they have that ability to leap most of the time. Toads do less leaping. They just kind of hop in little bits. They're not like super great leapers like a lot of the frogs are, but that's frogs and toads. That order is called, or class is called Anura. Newts and salamanders, there's about 420 species of those, and that's in the Caudata, or Caudata. Yeah, or I'm not quite sure what that one, but do you know what that class means? That word
No,
means?
I don't.
I think it has something to do with like the notochord, or
I would
like the
assume
backbone.
because
It has something to do with the
Caudata,
backbone.
probably.
Backbone. But newts and salamanders are some of my favorite animals because they look like Muppets. They have just a dopey little face, and they're so cute, and they think they are the top of the food chain, and they're not often the top of the food chain. And newts and salamanders do a lot of really cool behaviors as well that I like to see. And then finally, those Sicilians. There's like almost 200 species of those, which is a lot. So there's a lot of those that we don't know a lot about. Also, if you know what an axolotl is, they kind of look like a lizard, but they are not. They have external gills throughout their entire life. Those guys are in the salamander group.
They look like they're eternally smiling, and it's really cute.
Yeah, they are super cute. Okay, so another thing I want to mention before we go on is that, I forgot what I was going to say. It was a really cool fact about them. Oh, metamorphosis. Duh. Okay. Much like our invertebrate friends, we didn't talk about it much last week, but invertebrates and fish and amphibians go through something called metamorphosis. And there's two different kinds of metamorphosis. Metamorphosis is just changing from young to adult, from like hatching or egg to adult. The reason it's different from, we don't call our growth metamorphosis is because we don't have huge physical changes that happen to a lot of animals. There's incomplete metamorphosis, which is they basically, when they hatch, they look almost the same as the adults, but they just get bigger. But there's a difference between what we do and what incomplete metamorphosis is, I think. And complete metamorphosis is when they look completely different as a young animal and through the different stages of their life. So frogs, most frogs and toads go through complete metamorphosis. You guys probably already know frogs lay eggs, right? They have that tiny little egg right there. You can barely see it because it's so small. And then they hatch out as a little bitty baby, as a tadpole, right? And then they have 2 legs. It's kind of hard to see in this, but they start to grow their legs eventually. And then they end up with 4 legs and still have a tail as a young adult. And then the adult loses the tail and keeps the legs. So frogs go through complete metamorphosis. Salamanders, I'm pretty sure they just hatch out looking like mini salamanders, but their growth is very different, and I think that's why it's different from how we grow. Does that make sense to you?
Yeah. Cool.
All right, my friends. Are you ready to meet our first animal? Sweet. Oh, thank you, Mel. We try to be cute and funny. Just so you guys know, again, because these are particularly sensitive animals, again, absorbing things through their skin means that they can also absorb toxins from our hands, even things like hand sanitizer and sunscreen. So we're going to be wearing gloves today, handling these animals, as well as wearing that mask. Again, neither of us is sick. We've not shown any signs of it, and obviously we're not even sure that amphibians can get it, but rather be safe than sorry. So when you see us, we'll be having our masks and have some gloves. We're also going to be moving the camera today, so if you get a little motion sick, bear with us, because we want you to be able to see these guys very well. Now, this here is slughorn. Slughorn is a white tree frog, also called the dumpy tree frog, because they have this little mouth that looks like they're always smiling. So cute. They are very cute. Yeah, maybe sideways view. All right, let's see. Oh, that's not a bad view. Okay. A little bit dirty there. Okay, cool. So, white tree frogs are from Australia, New Guinea, and they've been introduced to New Zealand. They prefer pretty humid or moist forest environments, but they can be found in drier climates because to avoid drying out, like in a dry season, many of Australia's forests do have dry seasons, they actually will secrete like a really gross milky substance called carravinin, I think? Carravinin. It's basically a mucus coating that they cover their body with to maintain that moisture level in their skin so they can still breathe and they can still absorb nutrients that way. So they are really cool. That's one of my favorite adaptations about them. They also can change color. When she gets upset, she will turn light green. Right now she's kind of a purpley color, with some white spots on her, but she can turn light green as well. Ooh, yay, everyone can hear us. Perfect. Okay. Now, we're going to try to show you this frog. I'll do the camera moving up close. So we're going to try to move the camera for you guys so we can show you. So just look away a second if you get a little motion sick. Okay. All right, so she is right there.
Hi, cutie patootie.
The light, oh, there you go. So you guys can kind of see her. She's kind of just hanging out, and she's really pretty. I like her a lot. She's got very cool toe pads that help her stick to things, and she is a very good predator too. So we'll go ahead and move the camera back to where we were. Okay, almost there. Yay! And we're back. Okay. Hopefully you got a cool little up-close view of her. If not, that's okay. They are really cool little frogs. Now, she is a little on the small side, but she's pretty normal. They can get up to 3 to 4.5 inches big, so they're pretty awesome. The females are slightly larger than the males. Also, we're not, I keep saying she, however, Slughorn, we're not entirely positive is male or female. With a lot of frogs, it's really hard to tell the difference between male and female. There's not a lot of sexual dimorphism, which is what you call when the males and females look different. So there's not a lot of sexual dimorphism in a lot of frogs, or a lot of amphibians, actually. So we're pretty sure that she's a female, but we're not positive. And I'm not even sure what the qualifications are, because I think Josh, the main education keeper, made that call. So I don't even know how he knows that she's probably female. Now, these guys are arboreal, which I mentioned her sticky toe pads, and that's part of what helps her be arboreal. They have that ability to stick to the sides of glass as well as to the different types of bark, and it helps them to move amongst trees and not fall out of trees as much. And they eat just about anything that will fit in their mouth. Mostly insects and spiders, sometimes small animals, including bats, apparently, which is insane. And fun fact about amphibians, including frogs and toads. Most frogs only have an upper layer of teeth on their upper jaw. They only have teeth on the upper jaw. They don't have any, they have a lower jaw, they just don't have teeth on it. And toads don't have teeth. So they have to just gulp and hope that they can swallow down their food. Fun fact, frogs use their eyes to swallow. They blink their eyes and they kind of make this weird motion, and the muscles of their eyes help push the food down their throat. It's just the way their eyes are set up in their head. They literally use their eyes to help themselves swallow their food.
I did not know that.
It's really weird.
That's so weird.
If you've seen a frog like blinking, they kind of go like this. They use it like their eyes kind of going back. That's how they swallow their food. So their teeth, like we said, are not suitable for cutting their prey, so it has to be small enough for them to swallow it whole. All right, we'll bring her up to the camera again and see if we can get a good view.
And backwards, so everything's confused.
Oh, there you go, right there. That's a good one. Cool.
There you go.
Also, these little frogs, this is, again, a White's tree frog. They are mostly nocturnal, so they come out at night. They had pretty good vision to allow them to do that. I love this.
So
she's so cute.
chunky.
They catch their prey, again, like most frogs, with the tongue. They have a long, sticky tongue. For their smaller prey, if they have something slightly larger, they'll kind of pounce on it and then use their front feet to like put it in their mouth. It's kind of cute. Fun fact, frogs, the spit is what's called a non-Newtonian fluid, which means that it acts differently during different situations. So Newtonian fluids are like water, right? It's always going to be water. But if you've ever played with cornstarch mixed in water, and if you move fast across it or hit it fast, it's hard. But if you move slowly, you sink into it. That's what's called a non-Newtonian fluid. It acts differently, right? Frog spit is a non-Newtonian fluid. When it's in their mouth, it is not particularly sticky. It just sits there in their mouth. When they flick that tongue out and it hits a bug, it hardens and makes the stick to the bug, and that's how they can haul that back in their mouth. Fun fact. Super cool. I love talking about that fact, too. All right, my friends, a little bit more about them. They they reach sexual maturity at about their second year. These guys can actually live quite a long time, up to 16 years in the wild, but up to 20 in a zoo setting where they're well taken care of. Slughorn here, we're not positive how old she is. We've had her since 2008, I think I said. So she's at least probably 12 to 13, if not a little bit older. And they can live quite a long time. They'll hibernate a little bit in their, or I guess they're not hibernating. They feast a few days before their breeding season. So they just go nuts and eat as much food as they possibly can before their breeding season in their summertime, which is North America's winter. And then they can lay 150 to 300 eggs, and they lay them in water. Now, I didn't mention it earlier, but frogs' eggs are jelly-like. They're like a gummy bear almost. They're very soft, they don't have a hard shell, and they have to be laid in water, or they dry out and the eggs don't hatch. So they lay those eggs in water, and they usually hatch within like 28 to 36 hours, so like a day, day and a half, and then the babies hatch out. Again, in water, also, they're tadpoles. They're tiny, they swim around, they don't have legs yet, and it takes a few weeks to go through those different stages of metamorphosis. All right. Any other fun? Ooh, we have lots of fun facts on this one.
She's
Cool.
so fun.
Oh, metamorphosis occurs in a 2 to 3 week period, so it doesn't take very long for them to get to their young frog size, and then they just keep growing after that. Now, fun facts. This is one of my, I love amphibians. They're super cool. They're super slimy and weird, but they have so many cool things about them. One of those is they have what's called the parotid gland, which is where the poison is secreted. It's usually on the upper side of their neck, kind of on the top a little bit. Hers are kind of hard to see. You can see her ears, but I don't know if you can see her glands.
Yeah, I don't know.
But all frogs and toads that we know of have them, but not all frogs. There we go. Not all frogs and toads are poisonous. So that parotid gland is where the poison comes out of, but not all of them secrete poison. So it's a really interesting thing too. Now, when threatened, these guys will submit an ear-piercing call. Luckily, we've never heard that here at the zoo, but it's probably enough to frighten whoever's trying to eat them, and then they can run away. So a really cool little frog there. They're not a toad. There are a few differences between frogs and toads, and we'll talk about more of those later. So these guys actually, again, they're not poisonous, but the extracts from their skin have actually been used to fight staphylococcus bacterial infections that cause abscesses and lower blood pressure. Oh, are they used to lower blood pressure?
Used to lower blood.
Okay, so those extracts are also used to lower blood pressure as well as treating cold sores too. So those peptide extracts, the part of the skin, are from the parotid gland. So they're not poisonous, but they still have uses, which is kind of cool to learn about. They are the first species of Australian frogs to be described by colonists, named after John White when he discovered it in 1790. So 300, I can count, 200 years ago, 230 years ago. I think that's right. That sounds right. So yeah, they're a pretty well-known frog as far as from colonizing science, but they are a really cool frog in general. All right, that's it.
Bye, Slughorn.
Bye, Slughorn. While she's putting Slughorn away, I want to tell you guys the difference between poison and venom. Technically, they're sort of the same thing. It's really just the method of delivery. And what I mean by that is poison can kill you, venom can kill you. Poison can be just slightly harmful, venom can be slightly harmful. The intensity is not unique to poison or venom. The difference is how, again, it's administered. So venom is injected, whether that's with teeth, like a fang, or whether that's with a stinger. So technically wasps are venomous, or I think that's it. Wasps usually just stingers and teeth.
Yeah.
And spurs.
Barbs.
Yeah, so things like that, they inject the venom, right, into your bloodstream or your muscles or wherever that hits. Poison has to be ingested. So a lot of plants and berries and mushrooms and toads are poisonous. So not all toads, obviously. But poison has to be ingested, or you have to touch your mucous membranes, which is your eyes or your mouth usually.
Yeah.
Now, that means that if a toad bites you, obviously it doesn't even have teeth, you're going to be fine. If you bite or lick a toad, you're not going to be so fine.
Yeah.
So that's the main difference between poison and venom, which is why it's so cool that most frogs have poison glands, but they're not all poisonous. So, fun facts.
Yeah.
We're going to turn it over to Emily.
Okay, so we're actually going to be talking about a poisonous toad for this next animal, and it is the cane toad, which if you guys haven't heard of it, has recently gotten a lot of coverage in the media in the past decade or so, because most people know this as an invasive species, specifically to Australia. So it's also known as the cane toad, the bufo toad, and I think the marine toad as well, because they can survive salinity or saltwater levels up to 15%, which frogs can't tolerate salt water at all. Remember, they have that skin that not only helps them drink but also breathe, and that salt water to a frog can actually be very damaging. But these cane toads are super resilient and can actually live in saline water up to 15%. Now, fun fact: these guys are social toads. So a group of them is called a nest or a knot, which is slightly unnerving but also kind of cool. I don't like the phrase nest of toads. It's very weird. But this is Cheech. She's our cane toad. She's actually fairly small when it comes to cane toads. They can get bigger than this. They are larger than a teacup, if you want like a better image than like through a glass. They're larger than a teacup. She is approximately 4 years old, came to us in 2016, and they weigh about half a pound, 250 grams, somewhere in that weight range. Now, these guys are invasive to Australia, and I think parts of New Zealand.
Yeah, they're invasive to a lot of places.
Yeah, Hawaii, the Caribbean, Japan, most Pacific Islands, specifically Australia, but they are native to Central America, tropical South America, and parts of the southern United States. So how on earth did these toads literally transverse the globe to get from the United States to Australia? In the 1800s, 1900s, Australia grew a lot of sugarcane, and that was eaten by the cane beetle. It was really bad. It was destroying these sugarcane fields, and cane toads love to eat. They will eat anything that fits in their mouth, and so people were like, hey, let's take these cane toads from their native habitat, let's bring them to Australia, they'll eat all these cane beetles, and it's going to be a great time, and we're going to be excellent farmers and stewards of an ecosystem. So they brought 101 toads over from the Western Hemisphere, brought them over to Australia. They bred them until they had about 3,000 toads. Then they released these 3,000 toads into the wild in 1935, specifically up in Queensland. And in Australia, they didn't have any natural predators, so their populations where they're native are controlled by, coyotes and natural birds, other natural predators.
Animals that aren't susceptible to their poison.
Yeah. But those didn't exist in Australia. Many people had already killed off some of the large predators on the continent, and without a large predator, the cane toad population exploded. Exploded to the level that we went from 3,000 toads to over 2 billion toads in less than 100 years.
Oh my gosh.
Yeah. Exploded. And these guys, like I said, they eat everything. They even eat pet food. So if people leave, have outdoor cats and dogs, all that kind of stuff, and they leave their pet food outside, these guys will eat pet food. They'll eat insects. They'll eat small mammals. Anything that fits in her mouth, she will eat it, and she will love it. And she has a super good sense of smell, so it really allows her to hone in on that food quickly and easily. Now, their population went from 3,000 to 2 billion. And part of the reason that happened is not only because they didn't have any natural predators, but because of the way that these guys reproduce. So most amphibians are what's known as an R-selected species, which in science basically just means that they make a bunch of babies that are energetically cheap. So as opposed to us, we make 1 to 2 offspring that we have to carry in our body for 9 months and then care for them for 18 years. That's energetically very expensive. These guys produce between 8,000 and 3,500 eggs at once. And they can do this.
Wow.
Yes, and they can do this twice a year.
Oh.
So one female can lay between 16,000 and 70,000 eggs at once.
Wow.
Now, that doesn't mean that all of those toads are going to survive. The point of being an energetically cheap species means that you're going to lay a bunch of these eggs and, you're okay with some of them dying. They're not all going to make it. That's life. So only about half of these eggs that the cane toads will lay will grow into adulthood, but still, I think I did the math. Yeah, that's still assuming that half of every single female toad, half of the eggs that she lays, 21,500 of her eggs will still reach adulthood. So, yeah.
Oh my gosh.
It's insane. So assuming that happens for every single female cane toad, that you can easily see how the population very quickly went from 3,000 to 2 billion. There we go. Super speedy. The eggs hatch anywhere from a day to 3 days after laying, depending on environmental conditions. And the tadpole stage can last anywhere between 3 to 20 weeks. Again, it's very dependent on the conditions in which the female decides to lay her eggs. So if it's a super great, super bountiful environment when it comes to nutrients and very safe for these little tadpole babies, they'll metamorphosize in 3 weeks. However, these guys reach sexual maturity a little earlier than our White's tree frog. It takes them about a year or so to reach sexual maturity in the tropics. So like in South America, Central America. However, in Queensland, in Australia, it takes them a little bit longer to reach sexual maturity, which is a good thing in this situation. It takes about 18 months to 2 years for the Australian cane toads. Now, while Cheech is very small, she is part of the species that is the world's largest toad. Cane toads are very big. They're very big.
Yeah, like we said, she's a little small. How big can they get?
I don't know if it said how big they can get. I just wrote half a teacup, or size of a teacup.
I have heard that they can get this big. So she's about this big right now. I think they can get like this big.
That's so unnerving. We already said that they can tolerate saltwater environments. So their scientific name is Rhinella marina. Marina being marine, so like environments. So I don't know if I said it already. Don't know if I prefaced it, but these guys are poisonous. They secrete bufotoxin and bufotenin from their parotid glands. Can you see hers?
There are these big puffy pouches next to her head. So you got her eye, and then right below her eye is her ear, and then the big puffy area right next to her ear is where that gland is. It's kind of hard to see.
Yeah, so she secretes her bufotoxin, bufotenin, hence the other common name, bufo frog, from those parotid glands. And when she secretes it, it kind of looks like Elmer's glue. It's a milky white, sticky substance. And this is the poison. Now, typically for humans, if you are licking toads, which we'll talk about in a little bit, or if for any reason you're coming in contact with this bufotoxin, most of the time it will just be extremely painful. However, people have died from eating cane toads and eating their eggs. So it can be fatal to humans if you are physically consuming the poison. However, if you're like touching it in low to moderate quantities, it's just gonna hurt really, really badly. However, this can be extremely fatal for like smaller vertebrates and invertebrates.
Which is why they're going nuts in Australia.
Which is why they're going crazy in Australia, because they're just like, I'm gonna kill everything that touches my poison, and I have no natural predators. It's cool.
Fun fact: did you read about the hawks that they're starting to learn how to eat them?
No.
Fun fact, so some hawks in Australia are starting to learn how to eat these guys they catch them and then they flip them over and eat them from the belly, which is awful for the toad, but that way they don't get the toxin, so they're able to eat it and survive. So some of these hawks are learning how to do that, which is kind of cool,
Which is cool. Yeah, and very important.
Yeah.
So, I talked about toad licking. We're gonna elaborate on toad licking.
Cheech says don't do it.
Don't lick toads. Don't lick any wild animal. Don't put your tongue anywhere near a wild creature for like so many reasons. But so if you come in contact, like if this was cane toad and I just went like this, and I was to touch it and get a load of its bufotoxin through my hands, that would hurt. However, people have learned, because people are people, that if you lick the cane toads carefully, you will get enough of this bufotenin to actually cause you to mildly hallucinate. So people will go out toad licking and lick these toads and like start hallucinating, and that's so bad because don't go lick toads and hallucinate, but also like that can hurt you. You can't regulate the amount of bufotenin that these frogs are secreting, and like if you get too much, then you've literally just swallowed poison. And you can probably imagine how that turns out. However, unfortunately, cane toads are not the only toad that people go a-licking. In the United States, there's the Colorado river toad that also secretes bufotenin. It lives in the Sonoran Desert, and it has also been known to be subject to toad licking. Don't lick toads. Don't lick any wild animal. Don't do it. Don't put your mouth near like anything wild. It's just so many bad ideas. But the way this poison works is it's a neurotoxin, which basically means it impacts your nervous system. A lot of poisons and venoms are going to be neurotoxins because it's one of the most efficient ways to like immobilize prey. And neurotoxins are not a fun time to have in your body. So if you can avoid it, aka don't toad lick, don't do it. Don't do it. Does anybody have any questions about toad licking, about Cheech, about the tree frog, about amphibians in general, about invasive species, feel free to drop it in the comments if you do. Okay, so if not, that's totally fine. If you do have a question that comes up, you know, when we're talking about another animal, again, always feel free to drop it. If we don't get to it during the video, we always go back in the comments during when the video is over, and we'll respond to each one of them individually. But now we are going to kind of move away from toads, which were in the order Anura, and we're going to start talking about a salamander, which is in the order Caudata. I'm going to go get our little salamander friend, and Katie's going to tell you all about them.
All right. I will also allow like 10 seconds of awkward silence to see if Facebook is going to catch up with telling us if we have any comments. So I'll give you guys a minute. We're so glad everybody's here. Thank you for those of you who stuck through. If you're new in here, awesome. We are talking about amphibians today, and they are a really weird and super cool group in general. All right, we are also moving a bit closer to, actually we're moving back to Montana. So we were talking about white tree frog, which is from Australia. We're talking about the cane toad, which is introduced in Australia, invasive in Australia, and from South America. And the last animal we're going to talk about today is the tiger salamander. Tiger salamanders are from North America. They live here in Montana, which is pretty cool because, again, they are a cold-blooded animal. So being able to live in a cold place like Montana is pretty awesome. Just to review what cold-blooded means, cold-blooded just means that their blood temperature is regulated by the environment around them and not internally. So we are warm-blooded. That's why we eat so much. We use the food energy to warm our blood and keep it at a constant 97, 98 degrees. Cold-blooded animals, no matter how much they eat, it's not going to warm their blood. So now we have our friend Simon. Simon is a tiger salamander. He is adorable. I think they're adorable. This is the one that I think looks like a Muppet. Let's see if it'll focus on. Right up a little bit.
Oh, he says, he's shy. Yeah, you just want to explore, don't
So they
you?
kind of live throughout the mountain. Actually, I think throughout most of North America, if I'm not
They're
mistaken.
the most widespread salamander species in North America.
They're the most widespread salamander species in North America, which is really cool. Now, they live in U.S., southern Canada, and eastern Mexico. So they're also probably one of the more northern ranging salamanders, I would think. They don't weigh very much. Ours weigh about a stick of butter, about 100 grams or so, about a quarter of a pound. About 6 to 8 inches long. They can get a little bit bigger and chunkier. And they can live like 12 to 15 years. So they can live quite a long time for an animal their size. They eat worms and insects and sometimes small frogs. They'll eat other small salamanders, even baby rodents, so little bitty mice, baby mice. And their predators include just about anything bigger than them. Snakes, bobcats, coyotes, hawks and falcons, and badgers and foxes, just about everything. I'm sure raccoons would be on that list too, because raccoons love to eat everything. Now, they actually have pretty good eyesight. Their eyes are really small on the top of their head there, but they're really cool, and they have decent eyesight. But they actually use their sense of smell more. Is he?
He's like super active and he wants to look at me and the camera.
He's very active right now and trying to crawl everywhere.
Okay, we're just not.
That's okay. That's all right. I'll fix this.
Here,
There we go.
Maybe I'll do this.
There you go.
There we go.
There he
There
is.
you go. Now you look at the camera.
See, look at that little smile. He looks like a Muppet. I love it. So yeah, these guys are really cool. They are a stalk and munch kind of animal. They don't really have a long, sticky tongue like a frog or a toad does. So they actually just chase after their food. They're called a tiger salamander in part because of that.
Hi!
Because of the stripes, but also because they're pretty voracious predators for an animal their size. They are not poisonous. They do have actually, I don't know if they have glands, but there are several newt species that are super poisonous. And they're often bright colored to warn their predators away. These guys are not. They're just really intense predators. They're also called mole salamanders, partly because they are partially fossorial, meaning they spend a lot of time underground. So that's partly why they're called mole salamanders. Their whole group of related animals is actually called mole salamanders. Now, when these guys have babies, like the frog, they do lay a bunch of eggs. They lay about 100 eggs after 2 days of courtship. So cute. And then they'll migrate to the breeding ponds in the late winter, early spring. And then they can become sexually mature about 2 years old. They'll lay those 100 eggs after the 2 days of courtship, and then they hatch 4 weeks later. So they actually have a longer time to develop an egg compared to a lot of the frog species that we've talked about. And the larvae, the babies, will stay in the pond for up to 2.5 months until they're adult-sized. Again, that metamorphosis. And then, so again, partly fossorial, their burrows can be up to 3 feet deep, which is really, that's like a lot. You can't even see it on camera. That's really deep, right?
It's like 3/4 of my body.
3/4 of educator Emily's body. And only one species, they're one of the only species able to live in arid or dry North American interior. So again, they live throughout the United States, and the reason they can live in places that aren't super humid all the time is because they burrow, and underground, it's more humid. So that's how they're able to adapt to dry environments. Because of that burrowing habit, they're called the mole salamander. Super funny. And because they can breathe and drink through their skin, this, like we said earlier, it means they're susceptible to environmental toxins and pollutions. So again, if you go out in the summer when we're, finally, it's okay to go outside, and if you find one of these guys, it's super cool to admire them, super cool to take pictures and look at them. But we don't recommend touching them unless it's like they're in imminent danger. Just because, like, if you put on bug spray that day, or if you have put on sunscreen, they could absorb that into their skin and get sick. But because of that, also in a broader view, amphibians can often be an indicator species, which is an ecological term meaning that if something happens to that species, there's probably something changing or bad in that habitat. And because amphibians are so sensitive, they can sometimes be the indicator species that something's wrong. So often if the frogs go away, or if the salamander, you can't find salamanders where there's supposed to be a lot of them, that might mean that there's a toxin in the environment, or that something is just not right. And so that's something to look at to see how healthy your environment is. If you find a salamander in your garden, for example, that means you've got a nice, healthy garden with lots of bugs in it for them to eat, and chances are they're not going to bug you guys. Now, I'm going to talk about those poisonous salamanders and newts because he's not, but poisonous salamanders and newts, they do this really funny thing. So most of the time there's one, it's called the rough-skinned newt, and it's one of the most toxic newts in the world. And when they get scared, they're already like a dark orange on top, but when they get scared or threatened, they flip their head back, they basically like try to plank on their belly, I guess, and they just try to show off the fact that their belly is bright orange, be like, hey, don't touch me, I am super poisonous. And it's super weird to see them do. They like flip their tail up. It's super cute too. So now Emily just left here, and you might have heard a little spritzing in the back. So again, because their skin needs to stay wet to absorb oxygen, we do have a spray bottle behind us to help keep our animals nice and wet because they need to be. All right. I have one more fun fact for you, but I'm also going to ask for questions right now before I tell you the fun fact. And that way, maybe by the time we're done with fun facts, you'll have a question for me. So if you have any questions about the frogs, the toads, or the salamanders, or anything else about animals in general, we'd be happy to answer that too. So think about that, type in any questions you might have, and I'll tell you about the fun fact. Salamanders can regrow their limbs. What? Yeah. So if something happens to them, it takes a little bit of time, but they have certain cells in their body that actually speed up the regeneration process, and they can regrow like toes and legs. Yeah, go ahead.
Is that in any way because they're related to like other reptiles that can do that, like the leopard gecko, or is that convergent evolution?
I think that's called convergent evolution. So Emily was asking if they can do that, if they can regenerate limbs, because excuse me, I'm about to. Excuse me. Emily asked if they can do that because they're related to lizard species who can also do that. Think about our leopard gecko friend that we met way back when we first started these Facebook Lives, our leopard gecko friend who can drop her tail and regenerate that. And I'm pretty sure they're not that closely related. I'm pretty sure it's just because it's something called convergent evolution, which is what happens when two very different animals, not super closely related, are in a similar environment or find an adaptation that's similar and it benefits them both. So
Think like wings,
like wings, right?
and insects and like butter or and birds.
And birds, yeah. So like insects and birds are not even remotely closely related. Very, very, very so distantly we don't even know how distantly related, but they both have wings that work, right? That's called convergent evolution. Same idea with salamanders that can regrow their limbs and lizards that can regrow their limbs. They do have a similar body plan, meaning they have the 4 legs that sprawl out to the side. They have a long tail, but they are very different in a lot of other ways. All right, my friends.
You're an extra active boy today.
He's very active today. Again, these guys are mostly nocturnal, but they do tend to have fun being all active with people. They are. So, I think most of our animals are just really are going to love it when people are around again, especially Sydney the kookaburra, because it's been very quiet here at the zoo. So hopefully, just a review for those of you who weren't there at the beginning, we are opening to the members on May 4th. Again, this is all a test run, subject to change just because who knows what's going to happen with all the virus stuff. But we are opening to the members, zoo members, on May 4th. And then we theoretically will open to the public the week after in a very limited capacity, limiting the amounts of people and no groups no larger than 10. So come see us, please. We miss people. And Mel says, you guys are covering the info really well. No questions here. Thank you, Mel. That makes us very happy. So I'll probably stick out here for a little bit longer. We can keep him out here if he's doing okay.
I'm gonna spritz him again.
We're going to spritz him one more time.
These gloves like evaporate the water.
Yeah, that's fair. So fun fact, the water that we use with our amphibians, we call it stale water because we basically take tap water and then leave it open for 48 hours to evaporate any chlorination in the tap water, and then it's safe to use with amphibians. It won't hurt them to use tap water on a very limited basis, like every once in a while maybe, but it's best to give them the dechlorinated water so they don't absorb that chlorine into their skin, because it can mess with their system just like anything, right? All right, my friends. Thank you guys so much for watching. Next week, we have a really fun plan for you. Okay, it'll be a little bit shorter of a Facebook Live. Our Facebook Lives have been really long, and we appreciate everyone who's been sticking through them. But next week's going to be a little shorter. We are going to be meeting 2 animal ambassadors that you have not seen on here yet. And I'm going to keep it a secret, and we'll try to give you hints through the week to see if you can figure out who we're going to meet. And it's also going to be not in our studio. It'll be upstairs. So definitely join us next Saturday at 10 a.m., and you'll see some really cool animals. And as always, if you have any questions or requests, send them to us. We do have a YouTube page where we've been posting all of these, and Emily's been doing some really awesome videos about cool topics. So definitely check out our YouTube page, which is ZooMontana. I think that's it for now. Oh, we're going to be posting on Instagram and Twitter twice a week starting next week. So join us because it's super cool, and we talk about different things that we talk about here on our Facebook page. So anyway, guys, thank you again for watching. We appreciate all of you. You're wonderful, and we will see you next week. Bye!
Oh, there you go.
There it is.
You are